Good morning, students. So here in the second model we have I want to explain the steering geometry. Okay, steering geometry. It is not now. I'll explain this one. It is not enough to simply place the front wheel on the hubs, stand them up straight, and devise a mechanism to swivel them left to right. The car could be driven up driven, but it would steer very poorly, and at higher speed it would become dangerous to handle, and also tire life would be short. The wheel alignment refers to the positioning of front wheel and steering mechanism that promotes ease of steering, provides directional stability, reduces tire wear to the minimum to secure easy steering, smooth operation, and the several front wheel alignment factor must be considered, such as camber, kingpin, or steering axis inclination, caster, toy in the toy out, and turning circles or angles, we can say. Now camber, the the camber diagram you may observe here. This is the camber diagram. Camber and kingpin inclusion. Okay, so tire center, this is the tire center line. Tire center line, kingpin is there, and center line is there, and wheel vertical line is there. Okay, here you have vertical lines. So what is that geometry? Actually, I will explain that one here with this, the theoretical part. Camber angle is the inclusion between the center line of the tire and the vertical. If the wheel are inclined or tilted outward at the top, it is called positive camber, and if the wheel are inclined inward the top, and it is called negative camber. It is also called as wheel rake angle. Front wheel are not mounted parallel to each other. Instead, they are tilted slightly outward at the top. This is done to prevent the top of the wheels from tilted inward too much due to the excessive load or play in the kingpin and wheel bearing effect. It is noted that to make the tire wear more uniform, tire should roll vertically on the ground. The tire will wear more on the slide than the other side. When it is tilted inward or outward, the positive camber causes the tire to roll it like a uh, tra- truncated cone. The positive chamber makes the wheel to toy out, and tire will wear more on the outer side. Similarly, the negative camber makes the wheel to and tire will wear more on the inner side. Initially, the wheels are provided with positive camber. After loading, automatically they come in come to vertical position. It is clear that when the vehicle is running with average load, zero camber angle gives maximum tire life. If the two front wheels are not provided with the equal camber, the vehicle will try to pull towards the side where the camber is higher. In the same way, if the wheels are provided with the equal camber, the ground road has a tendency to pull away the vehicle to the side of the road to over. Usually, slight higher camber is provided on the right wheel. In case of right drive wheels vehicles, which have more on the left side. For the left hand drive wheels, left hand drive vehicles, left wheel is sided with the higher camber. So likewise, the camber arrangement is provided for the different position of the vehicle. And now the kingpin angle and steering axis inclusion. Okay, this is the diagram which is required to explain this particular part. Kingpin angle or a steering axis inclusion. The kingpin or a ball joints are mounted in such a way that they slant inward. The kingpin inclusion is the inward tilt of the kingpin or ball joint center line from the vehicle, that is the angle between the vehicle and the kingpin. Angle between the vehicle and kingpin or ball joint. In case of kingpin, this is called kingpin angle. This is called kingpin angle, and if the ball joint are used, then it is called steering axis inclusion. Effect: kingpin inclusion in the combustion with the caster provides the electric directional stability. When the vehicle turns, the vehicle body is lifted up slightly due to the kingpin inclusion. After completing the turn, driver leaves the steering when wheel and vehicle weight causes the wheel to recover straight ahead position. The kingpin angle is kept about 7 to 8 degree, and the exact amount depends upon the wheel rake angle. This kingpin angle also uses suspension shocks to be transmitted to and absorbed by the heavy inner spindle and knuckle assembly. The inclusion angle or included angle and scrub radius. It is the angle obtained in the vertical plane between the wheel center line and the kingpin or a ball joint center line. It is equal to the camber plus kingpin inclusion. The kingpin center line, when extended, meet the road surface near the tire center line, and the distance between these two center lines at the point where they intersect on the road surfaces is called scrub radius. It is positive when the steering axis or ball joint center line meets the road surface inside the tire center line. If it meets the road surface outside the tire center line, the scrub radius is negative. A small scrub radius is desirable as it reduces steering wheel shock from the road irregularities and reduces steering front effect. The figure explains whatever the figure you are having here. This figure explains how the combined angle affects scrub the radius, and hence forces against acting to turn the wheel in rear wheel drive vehicle. It is seen that unless scrub radius is zero, a torque acts on to the turn the wheel always from the straight ahead position. The negative scrub radius causes the wheel to toy in as shown in the figure A. A positive scrub radius causes the wheel toy as shown in the figure C. So here you are having those figures A, B, C. A zero scrub radius keeps the wheel in straight position without any tendency to toy in or toy outside as in the figure B. In this case, wheel center line and kingpin or ball joint center line exactly meets on the ground. This condition is called center point steering. By experience, it has been proved that if the ball joint center line and wheel center line meets below the ground, it gives best results. If both the wheels are not provided with equal combined angle, the vehicle will pull towards the side where the scrub radius is high. Okay, now caster. Okay, caster. The kingpin are tilted slightly from the vertical as shown in the figure 6.15a. Here now this is the figure, and B. the angle between the kingpin center line and obtained in the plane of wheel is called the caster angle. If the kingpin center line contacts the ground at point in front of the wheel center, it is called positive caster, and if it meets behind the wheel center line, it is called negative caster. The caster angle should not exceed 3 degree. In modern vehicle, negative caster ranges from 2 degree to 8 degree. Effects: caster produces a trailing effect and hence gives directional ability by making the wheels to lead or follow the same direction as the vehicle moves. Incorrect caster angle results in hard steering. When the brakes are applied, vehicle pulls to one side, tendency towards to wander due to lack of directional stability. Example: caster angle provided on the furniture rollers and on the front wheels of the bicycles. The positive caster provides in both these these cases causes the wheels to pulled in any direction. Okay, toy outside out condition. Toy in and toy out condition. Okay, toy in and toy out condition. You are having diagrams here, toy in and toy out condition. Okay, we'll see what happens here in this particular system. Okay, the tie in is accomplished by placing the front of the wheel closest together than the back. When the view from the top, the vehicle is stationary. Tie in nothing but the difference between the center to the center distance of the rear ends and the front ends, B to A. If the wheel are set closer at the back and that at the front, that is then the difference of distance between the wheels at the front and the rear is called tie out effect. When the wheel is cambered, the tire engages the road at angle. Since the tire will adapt itself to the road, rolling edge of the tire will not be the right angle to the center line of the wheel. This will cause it to roll in the form of truncated cone and thus causes more wear or outer surface of the wheel. The purpose of toy is to neutralize the cone rolling effect of front wheels caused by the camber angle. Therefore, the amount of toy depends upon the camber angle, and in the modern cars usually 2 to 4 mm. In same front wheel drive cars, initially toy out has been provided to counter the tendency to toy in and excessive steering linkage. Looseness will allow the wheels to toy out under dynamic loads. Excessive toy in or a toy out will cause tire wear. Okay, next, toy out turns. Toy out on turns. Okay, when the vehicle takes the turn, inner wheel must turn a smaller turning circle than the outer wheel. This causes the wheel to toy out on turn due to the difference in their turning angle. This essential action is allowed by bending both steering arm so they angle slightly towards the center of the vehicle. When the vehicle takes turn, the steering arm on the inside of the turn swivel more sharply due to angle of the arm at this point. Now steering gears, we'll explain now steering gears. So this much part is there, so I'll do remaining part video in the next class.